Mass spectrometry is the most direct and accurate method for determining atomic and molecular masses. The device used to measure the mass and the abundance of charged particles is called mass spectrometer. A graph of the intensity of the signal from the detector versus the mass of the ion is called mass spectrum. The main parts in a mass spectrometer is ionization chamber, acceleration chamber, electromagnetic chamber, vacuum pump, amplifier, and chart recorder. A gaseous sample is bombarded by a stream of high-energy electrons. Collisions between the electrons and the gaseous atoms or molecules produce positive ions by dislodging an electron from each atom or molecule. These positive ions are accelerated by two oppositely charged plates as they pass through the plates. This positive ion will pass through into an evacuated tube exposed to a magnetic field. As the particles zoom through this region, they are deflected according to their mass-charge ratio. The lightest particles are deflected most and the heaviest particle least. At the end of the magnetic region, the particles strike a detector which records their relative positions and abundance. A graph of the intensity of the signal from the detector versus the mass of the ion is called mass spectrum. Analysis of a mass spectrum gives both the masses of the ions reaching the detector and their relative abundance. The abundances are obtained from the intensity of their signals. Knowing the atomic mass and the abundance of each isotope allows us to calculate the average atomic mass of an element. Let's say we want to find out the mass of magnesium atom. When we introduce some amount of gaseous magnesium into the mass spectrometer, it will split into three different beams because magnesium consists of three isotopes. The beam that is deflected the most is the one belongs to magnesium-24 because it is the lightest among the three isotopes. Next, we have beams that represents magnesium-25, and finally we have the heaviest isotope, which is magnesium-26 that deflected the least. The mass spectrum that will come out from the detector will have three peaks indicating each three isotopes. The peak for magnesium-24 is the highest since it is the most abundant isotope in magnesium with 79%, followed by magnesium-26 with 11% and magnesium-25 with 10%.